Hello everyone, welcome to Introduction to Scikit-learn. The machine learning ecosystem has developed a lot in the past decade. The AI community is so strong, open and helpful that there exists code, library or blog for almost everything in AI. And Python is well built for machine learning and data analysis. It is because of the number of libraries it has. For example, NumPy, which can be used for scientific computation, Pandas, which can be used for tabular data analysis, Scikit-learn, which can be used for data modeling and pre-processing, and for deep learning, you can use TensorFlow, PyTorch, Keras, etc. Now, if you want to dive deeper about Scikit-learn and know what is actually Scikit-learn, we can say that Scikit-learn is the most popular library for machine learning, and it is most useful and robust library for machine learning in Python. As I said, it provides almost every popular model, and it also has efficient tools for machine learning and statistical modeling, including classification, regression, clustering, and dimensionality reduction. On the other hand, the best part of scikit-learn is you can get your hands on vast number of machine learning algorithms, and you can just try them out with minimal code adjustments. On the flip side, the library is well documented and maintained, so you can go and visit the library. Before you can start using the library, you need to have it installed in your computer. So to have it installed, you can either download it as a Python package using pip install, using this command pip install /u, then scikit-learn, or you can use, if you want to download it for the Anaconda environment, then you can use conda install scikit-learn. Once you have installed it, you can check the version of the scikit-learn you'll be using. For example, if I run this command, then I'll be able to see the version of the scikit-learn. So here you can see the version is 0.22.2.post1. So the version, by looking at the version, you can a question might pop up in your head that it is not old because it starts with 0. But as I told, this library is well maintained and well documented, and there is a large community which maintains this library. So you do not have to worry about the version. However, if before diving deeper into scikit-learn, let's go through the general pipeline of machine learning. The first step is accumulating data, and then you clean and prepare your data by deleting the null rows, or like taking some steps to fill up those null values, or if you have redundant rows carrying redundant feature values, then you must delete them, or you must find a way to uh, fill them up. And then you pick a model based on your prior knowledge or intuition, and which model will work on, which model will work better on this sort of problem you're given. Based on your problem, you can pick a model, because certain models are specialized for to do a certain task. So after picking up a model, you can train that model, and with that model you can evaluate the model, which is the fourth step of machine learning, using your test data. And after evaluating the model and looking at the accuracy and training and testing accuracy, you can judge whether the model has overfitted or not. And by looking at that, you can see whether there is a variance error or a bias error. So after looking at that, you can improve your model. So let's look at the two components of machine learning. So I'll go through all this very briefly. So in supervised learning, you clean the data, then split it into training and testing, and then you train your model. Then you give your model a score, then by evaluating it, and then you can improve your model. And in supervised learning, you have the corresponding labels with the features. But in the case of unsupervised learning, you do not have the labels. You have the raw data. You insert the raw data in your algorithm or your machine learning algorithm, and then your algorithm clusters it and gives it some labels all by itself. So now let's dive into the supervised learning using scikit-learn. So supervised learning can be of two types: classification and regression. So I'll show you some algorithms on classification and regression as well. So in classification, there are many types of classification algorithms that you can choose, such as linear model, support vector machine, nearest neighbors, stochastic gradient descent, and many more. So firstly, you need to import the important libraries that we'll be needing. And then from sklearn.dataset, you can load the wine data. And let's see how the data looks. And using the load wine function, I have loaded the data. I have the data in this variable. So let's, as we know that this wine data variable is a bunch type object from scikit-learn, and bunch type object is similar to a dictionary. So a dictionary has keys. So using this dot keys method on the wine data variable, you can see the number of keys it has, like what are the keys it has. So here you can see the key, and there are keys like data, target, target names, feature names. So let's see what are the feature names we have. So here you can see that there are a lot of features which corresponds to the quality of the wine. So let's see what are the target names we have. So there you can see there are three targets. So after looking at the targets, there are the wine is categorized into class 0, class 1, and class 2. After looking at that, we'll create a data frame from pandas. And to create a data frame, as we have learned in the previous class, you have to pass in the data parameter, you have to pass all the features. And in the column parameter, you can pass the feature names. So here you can visualize it. So the columns will be shown by the feature names, and their values, you can have their values in row ordered. And here you can see we only have the 13 features and 178 rows, but we do not have the corresponding labels or the corresponding target. So in order to add that, you can run this code. So I'll create a new column called class, and I'll pass the wine data target, because in the target we have all the corresponding labels. So let's look at the data now. So here you can see we have added a new column called class, where 0 represents the wine from class 0, and 1 will represent the wine from class 1, and 2 will represent the wine from class 2. So after doing that, as you know that this data is this data set is optimized, but you will not have an optimized data always. So for example, if you're recording data using some sensor, you might there might be some faulty data, or there might be some cases where the data is not recorded. In that case, you might have some null values. So your computer do not know how to work with null values, and your machine learning algorithm does not know how to do calculation with null values. So you need to find a way and to avoid those null values. And if you have redundant values, then your machine learning algorithm will be more focused on those redundant values, on those redundant rows. So you need to delete those redundant rows. So data pre-processing is a must if you're creating a data set on your own. So here you can see we do not have, using this wine on wine data frame, we have method called isNull, and on that I'm running the sum method. So you can see there are no null values. After looking at the data set and after cleaning the data set, so here ends the two steps of machine learning. And after doing that, we can also visualize the data. Visualizing the data is very important because you can see where the outliers are, or you can see how the data is distributed amongst all the features. So data visualization is an important step. So here you can see from pandas.plotting import scatter matrix. I have imported the scatter matrix function. So since there are 13 columns, I will not use all the 13 columns, but I have picked some of them. And because I've picked some of them because the otherwise the this diagram will be very large. There will be a lot of relations, like you get the idea like what it will be. So I've picked only 5 of the features and I've colored them based on on their classes. So here you can see for example, here you can see the relationship with magnesium and flavonoids. So um, this yellow color can be of class 0, this light blue can be of class 1, and this violet can be of class 2. So if you use these two features, you can see that your data is separable. If you have flavonoids and magnesium, if you carry through, if you want to do your machine learning with flavonoids and magnesium only, then you can just take those two columns and you can see from this matrix that this data is separable. So after visualization, um, you can go to the third step of machine learning, which is like picking a model. So before picking a model, you need to divide your data into training and testing set. So in order to do that, we'll drop the will pass only the will take a x variable where we'll have only the feature values, and in the y variable we'll have the corresponding labels. And from scikit-learn.model selection we'll import the train test split function, and using that function we'll pass the feature matrices as one parameter and pass the corresponding labels as y, and you will use a stratify parameter so that the data is evenly distributed, and will denote the what is the test size. So here we are using the test size of 25%. So you can get the idea that 25% of the data will be in the testing set and 75% will be in the training set. So after splitting it, let's look at how many samples do we have in the training set. Here you can see we have 133 samples in the training set and 45 samples in the testing set. After doing that, we come to our model selection. So here you can see I've selected the model called nav bias classifier. So since we have another video for nav bias classifier, I won't go into the nitty-gritty details of nav bias, but to give you some intuition, I'll say that nav bias is a probabilistic model, and it is based on conditional probability, which says that you have a prior knowledge, and using that prior knowledge uh, you will calculate the probability of an event. So there are 3 types of bias classifier, and one type is Gaussian naive Bayes classifier. And Gaussian naive Bayes classifier is good for making prediction from normally distributed feature. So from sklearn.naive Bayes, we'll import the Gaussian naive Bayes, and we'll create an object using the Gaussian naive Bayes class, Gaussian NB class. So the object name is GNB. So using that GNB, GNB has a method called fit. So using that fit, we'll fit the data of X train and Y train. So here you can see we have splitted the data into X train, and X train contains all the training features, and Y-train contains all the corresponding labels of those features. And using that, since this is a supervised learning, we'll also pass the labels and will fit the model. After fitting the model, we'll come to the fourth step of machine learning, which is testing the model. So let's see how the model works. Let's see what's the accuracy. Here you can see the model works really well. We have a training accuracy where of 98%. From this you can see that the model fits really well on our data. Means it has separated all the classes very well. Maybe it had made a mistake somewhere. That's why we are having a 98% accuracy, and you can see that the testing accuracy is 100%. So you from the 45 samples that we had in the train testing set, it made no mistakes. So it did not see the testing set, and since it did not see the testing set, the predictions, these are the predictions it made. So this predictions has matched with the true labels that we had in the data set. So for better visualization, you can import a confusion matrix function. So in the confusion matrix function, you have to pass the predictions, and to generate the prediction you have to use this gnv.predict. So predict is a method that, so it is a method which takes only the feature values, and using those feature values it can predict. So these are the labels it predicted. So 0 is the prediction for class 0, and 1 is the prediction for class 1, and so on and so forth. And after doing that, for better visualization, you can import the confusion matrix where you have to pass the prediction and the true labels. And using that, you can create a confusion matrix. And in the confusion matrix, you can see that we have no error. And for better visualization, you can use a heat map from the Seaborn where you have to pass the confusion matrix. So I have saved the confusion matrix in a mat variable. So using that variable, mm, I'll also pass the color map, the value of the color map, which will denote what type of colors do I want in the heat map. Then I'll pass the labels in the x-axis and the labels in the y-axis. And a note is equals to true means whether I want to show this values in the matrix or not, this 15, 0, 0, 18, and so on. So let's look at our confusion matrix. So here you can see the confusion matrix. So this is the heat map, and it's called a heat map because the here you can see the value becomes darker and darker if the number of value increases. Like if it's 20, this cell will be more darker and all. So you can use certain color map to create this classification matrix. Sorry, confusion matrix. And after that, let's go on to another algorithm which is called support vector classifier. So support vector classifier looks at the extremes of a data set and draws a boundary, also known as hyperplane. So what do I mean by the hyperplane? So hyperplane is basically this line. The line you can see here is called the hyperplane, which separates these two classes. So for instance, we have two classes here. For example, this is the green class and this is the red class. And this hyperplane separates both the class at an optimal distance. So this can be called an optimal decision boundary. So how do we plot this hyperplane? So this hyperplane is plotted with respect to the support vectors. So support vectors are the ones which are closest to the opposite class. What do I mean by that? By that I mean that these three are support vectors because this this sample point is closest to its opposite class. It's close. It is closest to a sample point of the opposite class, and this this is a support vector as well because it is closest to this sample point of the opposite class, and the red is a support vector as well because it is closest to the to its opposite class's sample point. And using this information, the hyperplane is drawn in between the class where the hyperplane is of equal distance from the support vectors of the opposite class. And and support the advantage of support vector classifier is it doesn't only draw a linear plane between to separate data. You can also use, for example, it takes a parameter called kernel. So in that kernel parameter you can pass either exponential functions, linear function, or whether you want the data to be separated using a linear pattern, or if the data needs to be separated using polynomial pattern. By polynomial I mean this shape. If your data can be separated using this shape, for example, if you have a data like this, so this data can be separated using polynomial very well. And for example, on the other hand, it can also use exponential patterns to classify data, to separate data. By exponential, what do I mean? The exponential curves can be in this way. So using this type of curves, you can also separate your data. On the other hand, it can also use sigmoid. So sigmoid curve can be of this shape. So these are some of the shapes that support vector classifier can use to separate the data. So after separating the classes, let's see how it works to separate the classes. So our basic intuition is that this data, the wine data, can be separated using a linear plane. So using a linear pattern, it can be separated. So let's see whether our intuition is right or not. Or you can either use poly here if you want to see whether it is separated using a polynomial pattern. So like the same way I showed you, you can import the class, then you can pass in the kernel parameter, you can pass linear, and you can, using the fit method, you can fit it with the training features and the corresponding y labels. After fitting it, you need to evaluate the model. So let's see what's the training accuracy and the testing accuracy. So you can see the model fits really well. So a linear pattern can be used to classify this wine data. So it has a training accuracy of 99 and a testing accuracy of 98%. So it's a very good accuracy. And let's see where did we go wrong. Since the testing accuracy is 98%, there is somewhere we misclassified. So let's see the prediction matrix. So if you want to see the prediction matrix, and I made a mistake here, I have used GNV. So I need to use svc.predict. So it was the result of copying my code from the previous cell, and because of that I did not change the GNV here. So let's print the predictions. So here you can see the predicted values, but as the testing accuracy is 98%, you went, there is a mistake somewhere. So let's see where the mistake is. So in the same way, you can print the confusion matrix. I won't go into the nitty-gritty details because I told all this earlier. So here you can see a class 1 wine is mislabeled as class 2 is misclassified. So let's look at another algorithm quickly. So ensemble classifier is basically you're taking the power from multiple decision trees. Like you're taking the power from the decision tree and you're using multiple decision tree to build a big forest, and those decision tree will one decision tree will give you a class, will predict a class, and in the forest of decision trees, each decision tree will predict a class, and on the majority voting and the maximum number of voting, the maximum number of classes that you got from the decision tree, you will create the final result. So the advantages of random forest that it can be used with large data set with many features, and using more number of trees would not overfit the model. But it is good for classification, but for regression there is another class called random forest regressor. So use that doesn't work really well, but the classifier works really well. So here you can see from sklearn.ensemble I have imported the random forest classifier, and in the random forest classifier I passed an n estimators parameter where I have passed 50, which by this I mean that I'll be using 50 decision trees, and with that I'll train the model, and after training the model I'll evaluate the model. So let's see what's the training. Oh, here you can see the model works really well. So you have a training accuracy of 100% and a testing accuracy of 100% as well. So the model fits really well on the training data, and it classifies all the testing data that it did not see previously correctly. So let's look at the heat map. So here you can see no misclassification. So let's look at another classifier, which is neural network classifier, and this falls into the classification domain of supervised learning. The most significant part of neural network is that the robustness it provides, because mm, after certain amount of data, your machine learning algorithm, the performance of your machine learning algorithm will flatten out. But the elegancy of neural network is that as you feed a neural network with more and more data, its accuracy gets better and better. So these neural networks are always hungry for data. Their performance do not flatten out that easily. So, and since we have more data now thanks to IoT and our advancement, technical advancement that we are having, that nowadays we tend to record everything that is happening in the environment, and due to all this we have a lot of data in the world, and as we have a lot of data and these models are coming into play, and these models perform so well that they're almost human error. So that's also called Bayesian error. So let's see how this neural networks works, and and to give you some intuition, I won't go into the nitty-gritty details of neural networks and how they work, how back propagation works, and all those stuff. But to give you some intuition, as you can see, the small units are calculating certain functions. So these small units are fitting some shapes to separate your training data. Your training data is a high dimensional data, like it contains a lot of dimensions. By dimensions, I mean the number of features. So those features are separated using this hidden unit. So each hidden units uh, calculates a function, draws a line or draws a curve, and using all those hidden units, a lot of hidden units. So it's working like a black box to produce a very elegant function of like, so a very, as I said, it produces a very elegant function that you couldn't have ever imagined. So it's like a black box. For example, it's producing a function like in the shape of like some sort of shape. Using all those hidden units, it's producing a function which can create this shape to separate your data, like to separate your data. So it's working like a black box. These hidden units are working like a black box, and it's producing this elegant function to separate your data in a higher dimensional space. So that's how neural networks are working. Now coming back to our implementation, let's see how we can implement neural networks. And from sklearn.neural networks, you can import multilayer perceptron classifier, and in the multilayer perceptron classifier class, you can, in the hidden layer sizes parameter, you can pass the number of hidden layers that you want. So number of hidden units that you want is, for example, I want here 7 units, and the activation function will be ReLU. I won't go into the nitty-gritty details of how ReLU works and all those, so on and so forth. But what I'll say is, ReLU speeds up gradient descent. For example, if you use sigmoid or tanh function here, your gradient descent will be slow. So the gradient descent is then algorithm by which you can calculate the cost function, and the weights and bias are updated. So let's see. Um, we fit the training data as usual, and after fitting the training data, let's see how our model works. And we have maximum iteration of 200 here. So for 200 times the data was passed into this neural network. So for 200 times there were forward pass and backward pass. So let's see what's the accuracy. The accuracy doesn't look very high. So can we say that neural networks are not working well? But as I said, the neural networks are very powerful, so it should work well. So let's change the maximum iteration. So you can say that, acha, like since other algorithms are working so good, the neural networks is so robust, it should work well as well. So let's change the number of iterations. So by looking at the accuracy, I can say that the model did not converge. Like we did not go to the lowest point where the cost is minimum. So let's increase the number of iterations we have to. Let's try with 1000 iterations. Let's see what happens with 1000 iterations. See, there is a convergence warning. So it's saying that the model hasn't converged yet. So let's use 10,000 iterations. We do not have the warning message again, and let's see what's the accuracy we have now. The accuracy doesn't look good either, so let's increase the maximum number of iteration. Oh, the accuracy is good now. So you can see that with your number of iteration, the accuracy is increasing. So this algorithm, this neural networks algorithm, is very robust to large data sets. And with maximum number of iterations, as you increase the number of iterations, your model converges. So after, and you can also increase the maximum iteration as per you like. So I have, you can add another 0 here and increase the iteration to see whether the model improves or not. So as usual, we can print the confusion matrix to see where we went wrong. And here you can see the heat map. So here you can see the class 2 wine is mislabeled as class, a class 2 wine is, two class 2 wines are mislabeled as class 1, and the class 0 wine is mislabeled as class 1, and so on and so forth. And after that we are done with the classification domain of supervised learning.